Okie dokie, so 5.4 point slope form. That's what we're doing today. We're going to write and graph linear equations using point slope form. So point slope form is y minus y1 equals m parenthesis x minus x1. So you'll see me during this lesson write this formula like, I don't know, 7, 8 times, something like that. You need to memorize this formula, okay? You'll do better in the class if you do. So, m is the slope, just like in y equals mx plus b, right? We're still using the same letters. y1 and x1 is an ordered pair you're going to pull out of the equation. If we're given a numeric equation that looks like this, when you pull out x sub 1, y sub 1, you always, whether you're putting it into the equation or taking it out of the equation, always use opposite signs. So if I say -4, the opposite of -4 is +4. So that's what I mean by opposite signs. The only reason I bring stuff like that up is we before talked about domain and range in the last chapter, 4.5, and I told you to list domain and range least to greatest with no repeats. And one of the questions on your quiz had 4 2s in a row for the range. And instead of writing it one time, no repeats, many of you wrote it 4 times, right? So if there are certain words that I say, like I just assume you understand what no repeats means. But if you don't get what it means, ask, please. I beg you. All right. So that's good for that. We're not going to do that slide, but we are going to do this slide. So I'll write down the ordered pair for you. -3, 6. Our slope is -5. First thing I'm going to do is write the equation again, second time. So when you were working with these equations, you're not going to plug anything in for this y and x. You are going to plug in for x1. Realize x1's at the end this time, y1's at the beginning. So when you plug those in, you're always going to use opposite signs. Okay, so just like always, xy is in alphabetical order. So here's my y1 right here. So what's opposite of +6? -6, right? So y minus 6 equals -5 is my slope. I never plug anything in for this x. And then opposite sign here, I'm going to write it using both negative, so minus from the formula. And then the 3 is negative. So the reason I say you plug in with opposite signs is because a negative makes a positive, right? Yes, negative makes a positive. So instead of plugging it in like this, I just wanted to show you that one time, and I'll never do this again. I just want you to know that that's positive. So I was like making that into a gigantic positive just because, so you can do the same. And I don't care if you even leave it like that on a, well, I don't know if we'll ever be back in person for you to take a paper pencil test. God, I would love that, but we'll see. Okay, so y minus 6 equals -5 times the quantity. That's how you say parentheses. The quantity x plus 3. Done. So my last class was like, my God, Evans, that lesson was super fast. So I'm trying to slow down a little bit. So if you feel like it's going too fast, please tell me. All right, I'm going to write that equation in tiny writing up there down here. So don't freak out. y minus 1 equals 2/3 times the quantity, parenthesis, x minus 2. So we're going to take that equation in point slope form and we're going to graph it. I'm going to write you some steps for graphing. So step 1, identify x1, y1. Okay, so in this problem, remember the x is at the end. Opposite of -2, positive 2. Opposite of -1, positive 1. Okay, now I'm going to make a coordinate plane. Again, if you don't have graph paper, buy some graph paper.
Wait, why is it the opposite? Like, why is it 1 instead of -1?
It's opposite because of this reason, right? If we plug in -3 minus a negative is a positive. So when we go the opposite direction and pull them out, it's the same concept. It's a good question. Thank you for asking. Okay, so we're going to graph this ordered pair. So 2 on x, 1, 2, 1 on y, boom. Okay, step 1, identify x1, pull the point out using opposite signs, graph the point. Step 2, identify the slope, which I'm just going to write as m. All of you should know that slope by now. And then once you identify m, I want you to count it out twice. Let's just say count m twice. So our slope here is 2/3. So I start at this ordered pair and I count, remember, y to the sky, y's on top, so I go rise first. So I go up 1, 2, and then I go to the right 1, 2, 3. Now sometimes when you graph these things, you run out of room. So I can also count down 2 and left 3. And I always want you to graph 3 ordered pairs, 3 ordered pairs. Because if you count incorrectly one time, you'll see you have a crooked line, and it's just an easy way to double check. Right, so I could have counted from this first order pair we graphed. I went up 2, right 3. I could have counted up 2, right 3 again. Right, I had room on my graph, but instead I just wanted to show you can go down and left. Right, so down is negative, left is negative, and the negatives cancel. So that's why you can do that. Okay. That's it. Any questions on this one? All right, next one. I'll write it bigger for you as well. Y plus 7 equals -4/5 x minus 4. So step 1 is identify the x1, y1. So who's brave enough to identify x1, y1? Waiting for more hands than just Anna. You're identifying x1, y1. More hands. This is what I do in class too when we're in person. You know how I love the awkward moment. Somebody else said, Dominic or Jackson, what is it?
4 and -7.
4, -7. Excellent. So the whole opposite sign thing is not that challenging, right? You can all do that. So let's graph 4, -7. So I'm going to count out up, or 4 on x, so 1, 2, 3, 4, and then down 7. 1, 2, 3, 4, 5, 6, 7. So you can see why if you're doing a quiz problem like this, it's kind of important to have graph paper because you can count stuff out accurately and not screw it up. Second step, we're identifying the slope. So what m is, in this case, m is -4/5. So the reason I brought up that point of counting out the slope in two different ways, because if I go down 4, I'm off my graph, right? So instead of going down 4, I can put this negative in the numerator next to the fraction bar or in the denominator. So I'm just going to move this thing to the denominator. So what happens then, on this one, I go down 4, right 5. On this one, I go up 4, left 5. Okay, so we're going to go up 1, 2, 3, 4, left 5. Right, and I have to go up 4, left 5 again. And your built-in double check is that when you connect the dots, your line is straight. That tells you did it wrong. Oh God, look, I miscounted. I wish I had done that on purpose just to make that point. And I saw somebody throw their hands up. That was good. I don't know who it was, but I got to see who it was now. Come on, cooperate. Clevis, nice. So I'm going to just count again. So I went up 4, left. Oh, I think I went, oh, that's why, because I wrote 5 here instead of 7. Why did nobody tell me that? Why, you people? You just wanted me to look stupid on a Friday. I see how you are.
Yeah, we just wanted you to look stupid. Yeah, you're right, Mr. Evans.
No, it's right. So 4, -7, and -4/5. Now I feel like I'm losing my mind, but I'll recover. It's all good. So we go up 4, 1, 2, 3, 4, left 1, 2, 3, 4, 5. That was the problem. I went left 7. Okay. Back on track. So we went up 4, left 1, 2, 3, 4, 5, up 4, left 5. That was pretty ideal, though, that I could show you what happens when your line's not straight. Got to go back and check to make sure you graphed it correctly, right? So that was like an unintentional teachable moment there. Okay, so to review, when you're graphing these things, pull out the order pair, opposite signs instead of -4, +4, instead of +7, -7. Then I graphed that point right here, identified my slope, -4/5. Then I looked and I was like, uh-oh, I'm going off the graph. So instead I moved the negative to the denominator. That enables me to go up 4 and left 5, up 4, left 5. All right. Anyone need more time on that after I screwed it up so many times? Here you good. Excellent. Okay, so you got to write this chart down. You don't have to write all this crap down, but write the chart down. And I'll tell you what to write from the problem. But this is time and altitude, and we're talking about a hot air balloon descending. Hopefully not that hard, because then you're going to crash. So time here in seconds. And the time goes 10, 30, 70, 90. I'll say that again.
I can't say it.
I know.
Oh, are you saying it? Sorry.
Yeah, you're good. So time is 10, 30, 70, and 90. 10, 30, 70, 90. The altitude, or y, so altitude is y, it's in meters. The altitude starts at 640, then goes to 590, then 490, then 440. 640, 590, 490, 440. Does anyone need me to repeat that? So this one is so much more involved. It's unbelievable. You have one like this on your quiz, so your intense focus is appreciated.
Wait, can you repeat that?
Repeat what I just said or the numbers?
What you just said.
You're going to have one like this on your quiz, so your intense focus is a good idea right here. The problem is way more involved than the previous one, and you'll see in a minute. So what they want us to do here, it shows the altitude of a hot air balloon during its linear descent. So that means it's a straight line, the descent, right? Not like this, because then everybody dies, but probably more like that, right? So what equation in slope-intercept form gives a balloon's altitude at any time? And what do the slope and y-intercept represent? So I kind of have to show you the difficult way to do this problem because you're going to see one like it. Yeah, I have to. Okay, I'm going to just choose these first two ordered pairs, which I'll write up here so you can see them. So we have 10. We have 10. Come on. 10 comma 640. Second order pair is 30 and 590. First thing I'm going to do is use y2 minus y1 over x2 minus x1 to find the slope. So I'm going to go to the next page and write some steps just so I have room. So we're going to find the slope by doing y2 minus y1 over x2 minus x1. So again, I never really think about that formula. I just subtract the y's and subtract the x's. And if I do that with y's on top, x's on bottom, that's the equation. You don't have to overthink it. So if I do 590 minus 640, we'll just do it over here. So 590 second y minus first y over second x minus first x. 30 minus 10. This is where I'm going to intentionally try to go slow just so you guys can understand what the heck's going on. So 590 minus 640 is negative 50. 30 minus 10 is positive 20. Raise your hand if you know how that slope reduces. What is the slope reduced? What can you divide top and bottom by? Show me with your hands what you can divide top and bottom by. Right? 10. So dividing top and bottom by 10, one really easy trick to do that is to just cross off the zeros. Right? Because all I did was just divide that by 10. And that only works if you have zeros on the end. Then you can just cross them off. And you cross one on top for one on bottom. So if I had 2 zeros to cross off on top, I could cross off 2 zeros on the bottom. Okay? So our slope is negative 5 halves. Now I just have to pick one of the two order pairs. I'm going to pick the first one. I'm going to plug into point slope. So after we get our slope, our second step, plug into point slope. Okay. When we plug into point slope, I'm going to write that equation for the third time, I think. Y minus y1 equals m parenthesis x minus x1. So writing the equation is kind of like building a frame for the problem. Like you can't build a house without the frame for the house. The frame of this equation just informs you about where to plug stuff in. So I'm going to plug in y1 and x1. So I have opposite signs always. It's positive 640, so it's negative 640 when I plug it in. My slope is negative 5 halves. So y minus 640 equals negative 5 halves times x minus 10. So when I do these things, I'm very deliberate. I'm very careful to make sure I don't screw anything up. Austin, question.
Wouldn't it be negative 10 for x on the second x?
Right here?
Yeah. Because you have to like change the numbers.
It is negative 10.
It looks like it's just like positive 10 because there's not another negative sign.
Ah, I see what you mean. So minus 10, negative 10 mean the same thing. That's like sometimes hard for some students to get over. I just think opposite signs instead of positive 10, negative 10, minus 10, same thing. That's all. Good question. That's a question a lot of students have. Thank you for asking it. Okay, so now we've got the equation in point slope. Up here in the problem, hold on. Let me read Ari's question. I think it was if there's another negative, but let me just see. Got it the last second. If there was another negative sign, it would be the same as adding 10. Right. It would be minus minus, which makes plus. Correct. Okay. So now we got to go what equation in slope intercept form. So we need to make this look like y equals mx plus b. We got double vision, Dominic. Freaky. Okay. So next we need to change it from point slope to slope intercept. So we've already written point slope like 18,000 times. Slope intercept, all of you guys know, is y equals mx plus b. Yeah, Dominic, my thing's been doing weird thing. My Google Meet has been turning my mic off periodically. So if it does that during this class, like all of you guys go like that, so I know my mic's off because I just keep talking. I have no idea. So we're going to change it to look like y equals mx plus b. To do that, I have to have the y by itself on the left side of the equal. To do that, down here, we're going to distribute this negative 5 over 2 into the parenthesis. I'm going to copy this to a new page because when I save these PDFs, it'll cut me off if I go too much lower. So give me 1 sec to do that. That wasn't quite high enough, but that's all good. So I'm distributing into the parentheses, so I get y minus 640 equals negative 5 halves times x. You just kind of smush them together, write them together. Now I'm going to do negative 5 halves times negative 10 kind of off to the side here. I'm also going to put the negative 10 over 1. When you multiply fractions straight across, top and bottom. Negative times negative is positive. 5 times 10 is 50. 2 times 1 is 2. 50 divided by 2, 25. Correct? So this.
Wait, what happened to the 10 you distribute? Oh, never mind.
You good?
Yeah, I was about to ask what happened to the 10 you like when you distributed negative 5.
Yeah, just multiplied those out and got that 25. Okay?
Wait,
Go ahead.
do you cross multiply there or
No.
just normal?
Straight across, top and bottom.
So then would it be negative 50 instead of
What's a negative times a negative?
positive? So wouldn't, but,
Okay. All good questions, right? Ari asking that question, kind of thinking out loud, is helping them to understand the math. So I encourage all of you to do the same thing. Now, the last thing I got to do to get y by itself is get rid of this negative 640. I do that by just adding 640 to both sides. this single problem takes up like the majority of the whole lesson. So y equals -5/2 x plus 665. And I said in the last class, 1 away from the devil number. Numbers you should never have in a high school math class, 69 and 420, right? And I try desperately never to have those numbers. Invariably it happens, of course, right? Okay, so the question asks us, let's go back to that, right here, what do the slope and the y-intercept represent? So I'm going to go to our slide here. What do the slope and the y-intercept represent? Let's wait for some more hands. Raise your hand if you know. Come on, take a risk. Be brave. All right, Volpe, what you got?
The slope and the y-intercept represent the equation to find y.
Okay, but like in real life, what does it mean? If it's at 665, the hot air balloon, what does that mean? And it doesn't have to be Anna, it could be anyone.
The starting point.
The starting point, right. So if I just kind of rough sketch a graph right here and say 665 is up top, that's like the max altitude of the balloon. So 665 is the max altitude. Okay? And then the -5/2, that tells you that it's going fairly steeply down, right? So y is the altitude, so it takes 2 seconds for the balloon to drop 5 meters. So what does the slope mean? M means it's -5/2. The y is the meters. The 2 is the seconds. So what does the slope mean? Every 5 meters it drops. That takes 2 seconds. Okay? So you might have to explain that at some point, so just be ready for that as a problem. That is it on this problem. Any questions? Because I know that was long and painful. You good? All right. So we got that. Okay. So I'm going to read these order pairs off to you. You want to sketch that graph on your paper. This top order pair is 1, 4. The bottom order pair is -2, -3. So 1, 4 and -2, -3. So the example at the top up here that says using 2 points to write an equation, it doesn't specify we're going to use point slope, but that's what this section is about. So yeah, we're going to use point slope. Y minus y1 equals m parenthesis x minus x1. How many people, just out of curiosity, think they already have that formula memorized? Like, close your eyes right now or look to the side, whatever you got to do. Try to say the formula right now in your head. How many people got it looking at the formula up there? 3, 4, 5. Okay, so you 5, I hate to say it for the rest of you, but you're the lucky ones because you memorize formulas easily. So how do you memorize formulas if you cannot memorize them easily? Organized use of color is the most powerful memory strategy there is. That's what the drag is about me having to use this black background, is that I can't use colors. I can only use black and white. I'm actually going to try maybe later on this class during work time to share my screen, because I tried to do that last semester, like in the spring, but it was too laggy. So I just want to see if it works, because this would be crystal clear if I can do that. but I can't use the organized use of color. So when I talk about organized use of color, you could have seen from that first slide how the book used the organized use of color right here. So sometimes this textbook will go overboard with the organized use of color. Like for me, I would have made X1, Y1 the same color and the M a different color. But that's an example of the organized use of color. So that's another memory strategy. Another memory strategy, second memory strategy, is just writing it like 10 times in a row, and you'll probably have it memorized if you do that. Okay? So let's go back to our slide. So this one, we have to get a slope and a point. That name of this section makes sense, right? Point, slope, form has a point and a slope. Math is nice that way in that it makes sense. So I could just choose a point. This one has both negatives, this one has both positives. Generally, I'd choose the one with both positives. Because I'm switching the signs anyways, it really doesn't matter which point I pick. So that's, you could pick either of the 2 points. It doesn't matter, right? So either of the 2 points. How would you find out the slope? Somebody raise their hand and tell me how they would get the slope. 2 different ways. Come on, you're better than that. Jackson.
One way is you could count like the boxes from one point to the other.
Good. What's the other way? Do you know that too?
Nope.
Y2 minus Y1 over X2 minus X1, right? You could use that formula that I really don't like. For me, no question, I would always count the slope out as opposed to doing that formula, especially because we have 2 negatives here. It's easy to screw that formula up. So I'm going to count rise over run, right? Y to the sky. So count up. And I'm just going to think about it, trying to model that thinking process as you do the math as we go here. So if I'm dealing with the y's, I have 4 and negative 3. If I subtract these, it's 4 minus minus 3, which is 4 plus 3. So when I count my rise, I should get 7. 4 plus 3 is 7. So I'm just like building that frame in my head and seeing if it proves true. So 1, 2, 3, 4, 5, 6, 7, and write 1, 2, 3. So we went 7 up. So plus 7 here and plus 3 here. Notice how, even though, like, if I just write 7, you know it's positive, I'm writing the plus just to enhance the fact that it is positive and it's not going to mess me up. So now I'm going to pick this point, and I'm going to use these as my slope, 7/3, right, as my slope. So my M equals 7 over 3. The ordered pair I'm going to use is -2, -3. Then I'm going to plug into point slope right here. Okay? So I have Y instead of -3, opposite sign positive 3. My slope is 7 over 3. Right? This X and Y always stays, so don't plug stuff in here. Always, always stays. And then plus 2. Instead of -2, positive 2. So to review, count out your slope, write it down, write your order pair down, boom, plug in using opposite signs, plug in your slope, same sign. Any questions on that one? You good? Anyone?
I have a question.
Go ahead.
So it doesn't matter which ordered pair you use. You just pick one and then plug in the y's and the x.
Yeah,
And then use the opposite sign.
The only reason it would matter, Ari, is if you're looking at a multiple choice answer and this isn't there, then you'd have to just look at the other one, and it should be -4, -1. So if we plug in using the other order pair, it'd be y -4 equals 7/3 x -1. So either or is good. Like when you guys, if you were in person and I gave you a test, I would accept either of these answers. But because you're doing it online, multiple choice, you could see this one or this one, and you just got to be ready for either. That was also a really good question, so keep asking. Are we good on this?
I have a question.
Fire away.
So would you not do this for, say you had like a table and it didn't have a steady rate of change? Would you just do the first two anyways, or?
If it doesn't have this steady rate of change, that's a good way to say it as well. It's not linear, so you can't do this. Right? So if it's a bendy line, then it doesn't work, essentially. Okay? It's good questions. All right, so we got -3, -4. Shay, you look so excited. And 1, 1. It's a good look. I got a new student today, and the kid at one point was sitting there in the lesson just like, oh, God. Then I pulled him into the chat room, and he's like, my God, man, that was so fast. So I'm trying to go a little slower now. So again, -3, -4, and 1, 1. First thing I'm going to do is count out the slope. So I go up 1, 2, 3, and I go left 1, 2, 3, 4. So +3, left 4. Remember, rise over run, y to the sky, y is always on top. So my slope here is 3 over -4. Right? And just to emphasize that point again, I can put that negative wherever the heck I want. I could do -3 over +4, right? Because if I count the opposite direction, I would go down 3 and to the right 4, down 3, right 4. So either way, I can put the negative. I just can't put 2 of them. I can only put 1. Okay, my order pair.
Wait,
Go ahead.
sorry. If you use to find the slope, if you do, isn't it y1 minus y2 over x1 minus x2, or is it y2?
Y2 minus y1 over x2 minus x1. But
Okay, so then wouldn't it be 1 minus -4, like 1 minus -4, which is the same as adding it, so it'd be 5?
You know what? I made my second mistake. Thank you for catching it, Ari. What's this ordered pair right here?
4, 3, -4, 3.
-1, 2, 3.
3.
1, 2, 3, 4. So
Yeah.
this should be positive right there. Okay? And then it works. I just wrote the wrong ordered pair there. And the slope still works, like I said. Okay, so let's choose the one with different signs because that's something new. So my x1, y1 is -3, +4. x1, -3, y1, +4. And we're going to plug into point slope. So I'm going to write that equation again. Y minus y1 equals m parenthesis x minus x1. Then I'm just going to plug in. So y, it was +4. I'm going to make it -4, opposite signs. Y minus 4. My slope is -3/4. This x I always write. This y I always write. And then my x value is -3. I'm going to use opposite signs to make it +3. Okay, so when you have a problem from a graph, like we did up here, make sure that you count out the slope, identify your ordered pair that you're going to use, and if you're doing it on the quiz, I would look at the quiz answers because it'll kind of tell you which ordered pair you should use. But so I could have also chosen 1, 1, so I'm going to write that equation as well, just so you can see them both. So we'd have y minus 1 equals negative 3 over 4 times x minus 1. Okay? So you just need to be ready to see either one of these on your quiz. All right. That's all I got for you. Quiz, homework, and quiz work is posted. I'm counting that quiz work now as a 0-point assignment. You don't get a perfect score. That's why I look at your quiz work so I can give you the partial credit back. That's about it. So we only have 2 more weeks of the semester. So those of you that are missing assignments, just be sure you're starting to work on those missing assignments to get those in. Because I will cut off missing assignments probably not this coming Monday, but next Monday. Okay, I just need time to grade stuff. So if all of a sudden I get 1,000 missing assignments, that's like 10 hours of my life. So just make sure you do your assignments on time, and you've got 1 week from Monday to turn in your missing work. I'll also put that out on IC so your parents know that as well. I'm also going to send a missing assignment report today. So if you know you're missing a bunch of work and you know your parents are going to get angry, make sure you knock out a few missings right now before class ends. Okay, you got 36 minutes to work on your homework and quiz. You may leave once both are done. Most kids did not finish. So you can turn your cameras off now. Ask me questions if you need to. I'll just be grading stuff.